everyone, and welcome back to another video dedicated to physics. Today we are going to discuss vector product of two vectors. In the previous video we discussed scalar product of two vectors and we studied the formula of scalar product and we got to know that it is also known as dot product, and we also got to know that the result of scalar product of two vector is a scalar quantity. Today we are going to discuss vector product of two vectors. Let's start. So vector product or cross product of two vectors A and B is a vector quantity. So first thing to note is that the vector product of two vectors give us again a vector quantity, whereas in scalar product we were obtaining scalar quantity. So the cross product or vector product of two vectors is a vector quantity whose magnitude is equal to product of the magnitudes of two vectors and sine of the smaller angle between them. So this is almost the same that again we want product of magnitude of two vectors. So in scalar product also we had the same thing. But in scalar product, we had cosine of the smaller angle between the two vectors. And here in vector product, we have sine of the smaller angle between the two vectors. Again, we have to consider the smaller angle. See, these you can see in the figure that A and B are two vectors. So this is also an angle between them. But we have to look for smaller angle, which is this one. Always look for the acute angle between the two vectors. Alright, so this formula we can easily understand. And now they are saying since the vector product of two vectors is a vector quantity. And what is a vector quantity? We know that vector is a quantity which has both magnitude as well as direction. So in case of scalar product, we were obtaining only scalar quantity. That means we were obtaining just the magnitude and we had nothing to do with the direction. So that was totally okay. But here the result is again a vector. So we have to be conscious about both magnitude as well as direction. That what is the direction of the resulting vector? And so this statement now says that whose direction is perpendicular to both the vectors. That means the final product, the vector product of two vectors would give us a vector quantity whose magnitude will definitely be given by this thing because it's a vector quantity, so both magnitude and direction will be there. So magnitude is definitely the product of magnitude of two vectors into sine of smaller angle between them. But what about direction? And the direction would be perpendicular to both the vector. It means perpendicular to both vector A and B. So here you can see this n cap is being shown. This is basically A cross B. So this vector, the vector which is a gray one shown by gray arrow, this is the final vector, the resulting vector from the vector product of these two vectors A and B. So this is represented by A cross B, and definitely this is perpendicular to both A and B. And this can be understood by right hand screw rule or right hand thumb rule. So we have these two rules with the help of which we can actually understand this meaning, this statement, that how the final resulting vector is equivalent to what is being said. As far as magnitude is concerned, that is totally fine, that we understand that that will be equal to product of magnitude of two vector and the sine of smaller angle between them. But what about direction? The direction they are saying is that it is perpendicular to both the vector. So for that we can understand that concept with the help of these two rules, right hand screw rule or right hand thumb rule. So we can consider this resulting vector A cross B as some other vector C. We can mention it as that it is a new vector obviously, which is a vector C. Often we write A cross B, or I should mention in terms of the smaller, as I have taken small a and small b as the vectors. So this A cross B is basically equals to AB sine theta dot n cap. So n cap is also there. And what is this n cap? N cap is simply the unit vector which is perpendicular to both vectors A and B. And obviously its direction can be understood by right hand screw rule or right hand thumb rule. Now you can see this is basically just a complete statement. We often write like this dot n cap. AB sine theta n cap is the answer for the cross product. And now this n cap, as I always say, that both the quantities on either side of the equal sign should be identical. So here, if we are saying that A cross B would give us a vector, that means on right hand side we should also get a vector. So sine theta would be some value. A and B. See, I have not mentioned arrow overhead. So that means here A and B are the magnitudes. Either we mention magnitudes like this or simply by the letter. This we already know. A, B and sine theta, they would be number. But then how would we make this side, the right hand side, as a vector? So we have to introduce something which is a vector. So that's why we have included n cap, which is a unit vector. It's a vector of magnitude 1. So that would only have direction. Its magnitude would be 1. So anything multiplied by 1 would be same. That's why we have multiplied it with n cap to make it look like a vector quantity. And definitely this n cap would be perpendicular to both these vectors, because we know that the final product would be a vector which is perpendicular to both the vectors. And if we have to find the magnitude of this, then we can write A cross B, obviously within the bars, and that is simply AB sine theta. This is the magnitude. Now where has the vector gone? Because in case of magnitude, whenever we find magnitude of any vector quantity, we only deal with the magnitude of it. We leave the direction part, because after all we are just talking of the magnitude. So this n cap is a unit vector. That means it has magnitude 1. So 1 multiplied by this thing would remain the same. So AB sine theta is the answer. Now let's understand what do we mean by right-handed screw rule and right-hand thumb rule. Right-hand screw rule, as you can see in this left image on the left side, we are having two vectors. One is vector u, which is here, and other one is vector v, which is denoted by this arrow. Now we are rotating this vector u towards vector v via this smaller angle theta. So right hand screw rule states that if we rotate the right handed screw, so here we are having screw and we are holding it in our right hand. Okay, so we are holding the screw in our right hand, and you can see that the broader part of screw is downward and the pointed one is upwards. And now you think, when you start rotating it anti-clockwise, basically this direction being shown is anti-clockwise. So if you do that, what happens? Anti-clockwise rotation, the screw starts moving upwards. It will start moving upwards when you try to rotate it anti-clockwise. This is the normal phenomena. Whenever you hold a screw in your hand and in your right hand, and if you are rotating it anti-clockwise, it would definitely go upwards. So this tells us the direction of the vector. The direction in which the screw moves, that is the direction of the resulting vector. So here, if we rotate the right-handed screw through the smaller angle from first vector to the second vector. So it's important. The direction is important, that which vector you are considering to be first one. And again here, see, we have considered the smaller angle. You can see that u and v have this angle also in between them, but we have not considered that larger angle. We are only considered the smaller angle. So when we turn the vector, we rotate the vector from, or the screw from first vector to second vector, then the direction of advance of the screw gives the direction of u cross v. So in whatever direction the screw will advance, that will be the direction of the final vector, the resulting vector. If you are holding the screw in opposite direction, suppose this is the wider part and now we are holding the screw like this, and if you turn it clockwise now, what would happen? It will go downwards. Okay, so direction really matters. Whatever we take, suppose this is our vector u and this is our vector v. So now if we rotate vector u towards vector v, and if you are holding the screw in your right hand and you are rotating it clockwise, where would the screw will go? Where would it go? The screw will go downwards. So then downward, this direction gives us the direction of the final resulting vector. So it's all about the direction in which we are rotating the screw. If you are rotating the screw upwards, like any anti-clockwise direction from u to v, then it will go upwards. If you are holding it in your right hand and you are rotating it in clockwise direction, like shown in the next diagram that I have drawn, then it will go downwards. So wherever the screw is advancing, that will be the direction of the final vector. So it's easy to understand, and you just do this yourself. Hold the screw in your right hand and try rotating it. You would know where it would go. If you are rotating it anti-clockwise, that means you are going from u to v. See, here we are going from u to v, simply means anti-clockwise direction. So the screw will definitely advance upwards. And if we go from, like in the other, this diagram, if we move from u to v, that means we are rotating it in clockwise direction, then definitely it will go downwards. So this is right hand screw rule. Right hand thumb rule. What does it state? See, here we are having a right hand and we have curl our fingers inwards. Okay. So when the hand is something like that we have our hand. So when we stretch our hand, we stretch our fingers like this one. In that case, this direction is basically the direction of vector A. Okay. And then what we do, when we curl our fingers like this, that means we are rotating our fingers, we are curling our fingers in the direction of vector B. So this is the vector B. And obviously in this, the angle would be the smaller one. So alpha is the smaller angle between vector A and B. So now the rule said that if we curl the fingers of our right hand in such a way that they point in the direction of rotation from A to B, again the statement is almost similar to the screw rule that we studied, that we rotate. In screw rule we said we are rotating the screw from the direction of first vector to the second vector, and here we are curling our fingers. The way we take our fingers inward, this is called curling your fingers. So when we curl our fingers of a right hand in such a way that they point in the direction of rotation from vector A to B through the smaller angle, here alpha is the smaller angle between two vectors, then the thumb points in the direction of A cross B. That is so simple. So when our fingers were stretched, that was the vector A, and now here this is the vector B, and we have curled our fingers in the direction of vector B by a smaller angle. So wherever the thumb is pointing, the thumb would point in the direction of third vector C. That is basically the cross product of two vectors. And obviously the thumb is in direction perpendicular to both A and B. And this is what we know. We know that the final vector has direction perpendicular to both the vectors. Here again, we have the case that suppose if we do the other way around, suppose when the fingers were stretched like here, and so this was the direction of vector A, and now we have curled our fingers in the direction of vector B, which is here, and this is the angle between them. In that case, obviously, if we do the rotation again, this is clockwise rotation, clockwise curling of fingers, you can say. In that case, thumb would definitely point downwards. So this would be the direction of final vector. Here we were curling the fingers. See, we are going from this way round to this way round. So we are actually curling our fingers in anti-clockwise direction. Here it is anti-clockwise direction. So definitely the thumb is pointing upwards. So up is the direction. So whenever we talk of the rotation in anti-clockwise direction, the advancement of screw or the direction of thumb is always upwards. And when we talk of rotation in clockwise direction or curling of fingers in clockwise direction, and that too of right hand, then the resulting vector would point in the downward direction. So this is very simple to understand, and in both the rules, right hand screw rule and the right hand thumb rule, we are using a right hand. In screw rule, we are holding the screw in our right hand and doing all the rotations, and in thumb rule, we are talking of the right hand and our thumb. In one case, it points upwards, and in another case, it points downward. So these are the two simple rules to understand what would be the direction of the resulting vector. Since we know that this cross product of two vectors give us a vector. So this was all for today, and in the next lecture we'll discuss the properties of cross product of two vectors. Thank you very much.